you how to calculate the IV flow rate of a solution in drops per minute. This would be useful if you run into a situation where you do not have an infusion pump, which will infuse at a particular number of mLs per hour, so you would need to calculate in drops per minute. So let's go and do our first example. The order is for 1,000 mLs of this particular solution, 5% dextrose in half strength normal saline over a 6-hour period. We have one bag of this solution, and the IV set is labeled as 10 drops per ml. That means 1 ml contains 10 drops. How many drops per minute would the patient receive? Okay, so our approach is that we want to look at what our answer, the units that our answer needs to be in, namely drops per minute. So we would put this at the end, at the far end on the right there. We'll do this again here, and we'll set up our equation. We know that we want 1,000 mLs to run over a 6-hour period, and we're told that 1 ml contains 10 drops, but knowing that drops needs to be in our numerator, we'll put 10 drops per ml. We also need to make sure that we deal with this hour. The hour period here needs to be converted to minutes, so we know that our conversion factor here is that 1 hour contains 60 minutes, and once we look and check and see how the units cancel and make sure that they cancel appropriately, our mLs cancel, our hours will cancel, and we're left with drops per minute, which is exactly what we want. So once we do the math, we will end up with 27.8 or 28 drops per minute. Let's do another example. We've got fluids, 1,000 mLs of D5W and 20 milliequivalents of potassium chloride. We need 1,000 mLs of fluids with 20 milliequivalents of potassium chloride every 8 hours. So what we have available is a bag of D5W labeled as having 15 drops per ml, and we have an ampule that contains 40 milliequivalents of KCl per 20 mLs. So the first question is, how many mLs of KCl would you withdraw from the ampule? So while I know that many of you, and we know that we need 20 milliequivalents, so I know you can probably do that in your head, but I think it's useful and helpful to be able, if the numbers were more complicated, to have a system of doing this. So our answer needs to be in mLs, so the mLs need to be in the numerator. We have 20 mLs that contain 40 milliequivalents of KCl. We know we need 20 milliequivalents. The milliequivalents will cancel. We'll be left with mLs, so when we do the math, we'll end up with 10 mLs of KCl. Now, to calculate our flow rate of the bag, we will look at this and go again that we know that we have 1,000 mLs that need to go over an 8-hour period. We know that our drop rate is 15 drops per ml, and we know that the GTT, or drops, needs to be in the numerator, so we'll set it up this way, and again, dealing with this hours that needs to be converted to minutes, we know that the conversion factor would be 1 hour containing 60 minutes. This then, if we go and cancel our units, we can see that we know that the mLs will cancel, we know that the hours will cancel, and we're left with drops per minute. So when we go through and simply do the math, we're left with 125 drops per minute. And so that is how you calculate the flow rate in drops per minute. I hope that was helpful. Thanks.